Good morning, everyone. Am I audible to you? Okay, thank you. Can anyone tell me who wished up in the last class? Okay, anyone could please respond. Did we discuss this numerical? This one? Please respond. Did we discuss this?
So we just going to discuss.
Okay, we have already discussed this, no? Okay, fine.
So,
Okay, then let's start a new topic today, okay? We will discuss about this breeze stress, okay? How it is. So I think all of you have seen the bridge truss. Any whenever you travel through a bridge, you have seen a truss. Okay, so all of you familiar with this. So this is a drawing of this truss where it is showing all the parts. Which part is called what? As you can see here, you see the joint, these joints in a bridge. It's called pin joint. Okay, all the joints are pin joint. In the upper there is a top chord, and the bottom there is a bottom chord, okay, and the in between it is a diagonal, so it is diagonal chord or it is called as wave. Okay, here also this is wave or vertical chord. So I think all of you know this, all the all of you have seen. So let's start. What is truss? Okay, so we'll discuss a little bit about the introductory part of our truss. So as you can know, truss, for a truss it must be a triangular structure. Okay, so a truss is a triangular structure, consists of three members normally, all are connected by pin joint. It is the most stable form of structure which is economical and carry maximum loads. I think all of you know this because in the bridge we need a strong structure so that it will withstand the load whichever coming to you, because along with the dead load there is always a live load coming on that structure. Okay, so there are some points, important points. Please remember these points. The first point is the loads are applied on the joints only. Okay, whenever there is a load in a truss, the loads are applied on the joint and it is transferred from the joint to all the members. Okay, so here is a truss, again it is showing. So whenever we solve this type of truss, so we need to find out the load coming out in each member from the joint. So how to calculate that one. Okay, for that, what we need to do, we need to count how many members are there, how many joints are there. Okay, in a truss. So you can easily count that. Okay, as you can see here, this truss. So in this truss, how many joints are there? Can anyone say how many joints are there? It is very simple. Just wait for a second. 8. Yes, Tashi. There are 8 members, as you can see here. If you count from any point, 1, 2, 3, 4, 5, 6, 7, and 8. After that, you have to count how many members are there. Okay. So can anyone say how many members are there? 13. Okay, fine. Very good. There are 13 members, as you can see here. If you count also, you will get 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Okay. So what is our aim? Our aim is to find out the load. Is it tension or compression? Whichever is coming on the members, we need to find out that loads in this type of truss. Okay. So we'll go one by one. I think all of you know this, how tension and compression, no need to explain it again. If it is coming outside, it will tension. It is coming inside, then it will compression. Everyone is knowing it. Okay. When the direction of force in the joint is outward, the member connecting the joint experiences tensile force. When the joint experiences inward force, then it is called compression. I think all of you know this. It's a very simple thing. You are familiar with this from your third semester itself. So here you see. Here you see. If we assume a force, okay, in this member, say this member, if we name it as this point as L0 and this is at E1, so P force into this L0 and E1, we are assuming a force, just for assuming, okay, just for explanation, I am telling you this. So if we consider that the assumed direction is positive, okay, then we can say that this member is subjected to tension. Okay, if the direction is negative, if the direction is coming out to be negative, then we can say that the member is going through compression. Okay, here you see what we need to do while analyzing a truss. Initially we have to assume the direction of the member forces, either tensile or compression, because initially we don't know. Okay, when we are going to start the analysis of a truss, we can't say that the member is subjected to tensile or compression, so we need to assume a direction. Okay, we need to assume a direction, either it may be tensile or it may be compression. Okay, so if our assumed direction is correct, then we will get a positive value when we solve the member. Okay, when we resolve the force and all these things, we will get a positive force. If we get a opposite direction, then it must be the opposite side. Okay, so there are some methods how we need to solve this process. Okay, so for that, the first method is method of joints. Okay, for this, what we need to do, in this method, free body diagram are used for joints along with the equilibrium equation. Along with this equilibrium equation, I think all of you know what is the equilibrium equation. We have already solved so many numericals in the earlier chapters. So there are three equilibrium equations, as you know: summation of V equals 0, summation of H equals 0, and summation of M equals 0. V means vertical force, H means horizontal force, M means moment. Okay, so how we are going to do this? Okay, so here you see, method of joints are only used when the number of unknowns are equal to 2 or less than 2. Okay, if there is a joint and along with that joint, if three members are connected, if we know one value, if we need to find out other two value, then we can go for this method. Okay, or if we know one value, if we need another one value, then also we can go for this method. Only for two unknowns or less than two unknowns, we can use this method of joint. As you can see here, we are taking a simple truss, a triangular structure. There are three joints. If we consider the first joint, this one, if we draw here, here you see there are three unknowns, R1 in this direction, L2 in the above direction, this is L3. If we know any one of these, then others two we can easily find out by this method. Okay, this is the just drawing the free body diagram of all these three. Okay, all these three joints, L2, this is L2, and this is for L3. We are drawing this. Okay, so this is our method of joints. So next, what is our method? Next method is our method of section. In this method, what we need to do, we need to divide the section by cutting in some point. Here, as you can see, that this one line, we are cutting this section in this portion. So after cutting, how it look like? It will look like something like this. One part like this, and one part will like this. Okay, when we solve a numerical, you will easily understand how we need to go step by step. So let's take a simple numerical. Okay, for your understanding, just take a simple numerical. See, we are considering a truss. This truss, okay, there are six joints. There are some loads are applied. Okay, so we need to calculate the member forces. So how we are going to solve this? Okay, so as I have already said, that what is our first step? First step is our, we need to assign the joint and members. We need to calculate, or we need to count how many joints and members are there. So as you can see here, how many joints are there? If we start from here in the top part, there are 1 2 3 4 5 6 joints are there. So we have written this joints 1 2 3 4 5 6. Similarly, we need to write the members, how many members are there. If we start from the top, there are how many members are there, we need to write it down. So here, how many are there? 1 2 2 3 3 1 4, like that. There is 1 2 3 4 5 6 7 8 9 members are there. Okay, so this is our first step. We need to assign the joint and members one by one. Now it is our first part is done. So what is our next part? So after this, we again naming the members as P12. Just put a P in place in front of these numbers. Okay, these numbers, just put the P. Okay, fine. I think all of you know this. You can easily understand. Next, what is our step 2? First step is our, we need to find out the reaction. What are the reaction coming out here? We need to find out. Okay, this is a fixed point. This is a roller. So there will be two, four reaction will come in this point, and one reaction will come out in this point. So there are three reaction, R4X, R4Y, and R6Y. So by using the equilibrium equation, we need to find out this reaction by using the equilibrium equation. I think summation of horizontal force you can easily find out, because there is only one horizontal force. This 20 is given. Both the direction is same, so direct 20 kN you can write. Next, summation of vertical force. When you resolve, you can easily find out the forces. It's a 70 kN is given. In the below part, there will be two reaction will come. Similarly, by taking the moment also, you can easily find out all the reaction. Okay, this is our second step. First step is naming the members and joint. After that, we need to find out the reaction. Okay, because by solving, by to solve the method of joint, at least we should know some values, so that we can easily resolve the forces in each joint. Okay, so next is step 3 is calculation of our member forces. Okay, For that, what we need to do, we need to consider each joint one by one. So we are considering the joint 4. You can consider any one, okay, because we are considering this joint because we already know one value r4y and r4x. Two values are known. If we draw the free body diagram of this joint, it will something like this, okay. If we draw free body diagram, two values are known and two is unknown. So from this we can easily find out the other two unknown by resolving the horizontal and vertical forces. These things are very simple, you can easily do. All of you please try to do this, okay, just don't read and keep this like this. All of you draw the diagram and all this thing and try to do one, try to solve this numerical by your own also. First you look the notes and try to do once. After that you can replace the loads and this length by some different values, and also you can try another one to solve like this, okay. Next, similarly we need to go for the next point for joint 1. If you take the joint 1, this is our joint 1. How many members are connected? 1, 2, 3. 3 members are connected. Joint 1, this horizontal force is there, and with joint 1, these 3 members are connected. And remember, in a truss, when there is a diagonal wave, it is at an angle 45 degree. Okay, remember this. So all of you know how to resolve. If there is an angle, along the angle it is cos theta, and against the angle it is always sin theta. So resolving the force again by using the equilibrium equation, you can also find out the unknowns p12, p15, all these things. Okay, so from here you can find out this p15 and p12. Okay, fine. Similar way, again you need to go for the joint 2. Again you need to use the equilibrium equation. Same way you need to repeat all for all these joint until if you are not able to find all the members connecting to each joint. Okay, so this is a very simple method, you can easily find out. All of you please go through this and try to solve one by one. Okay, so for joint 2 also, again first you need to draw the free body diagram this way. Let's draw the free body diagram. Check how many members are connected with that joint and which are the values you already know, and by using the equilibrium equation again you can easily find out the other unknown. Okay, similarly you need to go for the joint 5. Same way, only there is a little bit confusing in where the diagonal are come, but remember diagonals are always making at an angle 45 degree with the vertical or the horizontal angle. Okay, as you can see here we have drawn. And resolving the forces, by resolving the forces you can easily calculate the all the members connected to a joint. Okay, so all of you please go through this, okay, one by one joint and try to solve. See here you can find out p53 and p56. Excuse me, all the joints you can easily find out by this. Okay, let me show you once into the three part. So this is, you see, influence line for process. What is our main objective? Why we are doing this? Okay, we are doing this because we need to understand the bridge truss for flow system at load transfer mechanism, draw the influence line for the truss direction, and drawing the influence line for the truss member forces. So here you see whatever we did in our previous semester and all these things, what we did in the previous part also, what we discussed, we have studied the development of influence line for beams loaded with single point load, UDL, and a series of loads, which we have already discussed in your previous classes. We have already discussed, we have already solved some numericals about how it is, how the what I can say, how the structure look like when it is a point load, if there is a UTL, if there is a series of loads, if there is a combination of UTL and point load also. We already did this, okay? So in similar fashion, one can construct the influence line for the trusses. The moving loads are never carried directly on the main girder, but are transmitted across cross girder to the joint of bottom cord. Following section will explain load transmission of the trusses, followed by the influence line for the truss reaction and influence line for truss member forces. Okay, so as I have already said that all the loads are coming to the joint only. Okay, from the joint it is transmitted to the bottom cord from the wave and all these things. It is transmitted to the all the members. So here you see there is a typical cross section is given, typical truss. It is showing here in this. So we have it is already named in the lower part. It is L0, L1 is like this. It is naming, and above one it is U1, U2, U3, U4, and U5. So this is the front view of a truss. This is the floor plan, how it look like. Which one is which? It is already all showing. Here again you see there is important line. This line, this line you remember. It should be noted that for any load position, the truss is always loaded at the joint. Okay. So let's see this influence lines for truss support reaction, how it is look like. This is a truss given, all the distance and all these things are given. How this reaction, after finding out this reaction and all these things, how it look like. I have already shared this with you. All of you please go through this. You can easily understand by looking at it's very simply explained here. Here it is C, here it is given influence line for truss members force can be obtained very easily. Obtain the ordinate values of influence line for a member by loading each joint along the deck with a unit load and find member forces. The member force can be found out using the method of joints or method of section. The data paper is in tabular form and plotted for a specific truss member force. The truss member carries axial load. In the present discussion, tensile force necessary is considered as positive and compressive force necessary is considered as negative. We are considering tensile force as positive and compressive force as negative. So here also one numerical is given. So what it is asked in the numerical, construct the influence line for the force in member GP of the bridge truss shown in figure. So there is a truss given, simple truss is given, all the length and all these things given. So how we need to solve? All it is as you can see, it is as per the earlier one. Again, we need to consider unit load. We need to name all the force and all these things. Just resolve all the force by considering each joint. All of you please go through this numerical, okay, and try to solve this. This already well explained here in step-by-step procedure. Try to do this. After doing this, you can also easily draw this diagram also. Okay, so there are another one. All of you please try to solve this to numerical, okay. Without solving,
Hello, sir. Hello, sir.
yes, Michael.
Sir, please explain more in detail. We're not like really understanding, sir. Like, looking at it, we can really
Which part?
solve. Sir, I think we should solve, but we don't really understand, sir.
Which part, Michael? Hello.
Sir, like you just direct, sir. Hello, sir.
Yes, yes, I'm listening. You carry on.
Yes, sir. Like we can't just directly read. We, like we can't just directly read the notes and understand, sir. So I think you should explain more, sir, more in detail, sir. Sir, like sir, the first case, sir. Sir, can you go to the first question we solved?
Okay, this one, this one,
No, sir. First question, sir. PDF.
that handwritten notes or this one?
Yes, sir. Handwritten notes, sir. Yes, sir.
Okay, okay. I'm going through that again. Okay, don't worry. Which part is confusing, Michael?
Sir, the first joint, sir.
This one. When we consider the first joint.
Yes, sir. Yeah, the
Oh,
first joint, sir. Sir, can
oh,
you come down, sir?
okay, fine, fine. I think you have understand how to find out the reaction.
Yes, sir. Yes, sir. Yes, sir.
Okay, this up to this part is it okay? How we are
Yes, sir.
calculating this reaction?
Yes, sir. It's fine, sir.
Okay, fine. So when you consider this joint, na, you are taking a
Sir, look at this 20. It should be acting compressive, but it's drawn. You drew the arrow outside, and in
yes,
calculation we gave minus. See, so it's giving RU5 minus 20, but in the diagram it's showing tensile. I think that should act in the opposite direction. This 20, because it's minus 20, but in the diagram it's showing tensile.
yes, yes. See, Michael, what I have already said that we need to assume the direction. Okay, if you are getting the opposite direction, you can sense the direction. Okay.
No, sir, in the question, the direction is given inwards, but here we're drawing it outwards, sir. So if you see the question,
Yes, yes,
minus
yes,
20
yes.
is given
Yes, I understand
inwards, sir.
this. Yeah, this one. Now you are saying this.
Yeah,
This.
sir, minus 20 is given is inwards, sir.
Yeah, this is inward. Yes, this is inward.
And
So
that in direction also, we are using minus also, minus 20. But in the diagram, we are drawing outwards, sir.
this one. Now you are saying this one.
Yeah, sir, it should be inwards, sir.
Yes, you can.
Because even the calculation, we use RU5 minus 20. So I think it should be inwards, sir.
Yeah, this should be inward. Okay, this should be inward.
Yes, sir.
This is handwritten notes now in the from the previous semester. Some students' notes, so they may make a mistake. So I have already said you take the assume the direction as it is given, or whenever it is not given in the any member, you can assume a direction. So if your
Okay, sir. Sir,
okay, if your assumed direction is correct, then you will get a positive value. Means your assumed direction is correct. So if you are getting a negative value, then your assumed direction may be in the opposite direction. Okay. So
yes, sir.
every joint you have to assume the direction. If there is some known direction, then you can take that known direction. If other direction is not known, then you can assume that direction. Okay.
Okay, sir.
Yes.
Sir, but sir, I thought there should be a basis. Like, should we assume positive or negative direction? Because like we should have something to assume. Either we should assume
I
it as
think I
tensile or
think
we should
I
assume
think
as
you assume positive.
okay, sir. Okay,
It's
sir.
for easy for you. You assume, and you see when you take any member. Say I just wait. Say if you are taking this member, so your forces coming from this way, so there is no meaning of taking the direction in the opposite way. Okay, so you assume in the
Yes, sir. Yes, sir.
positive way only, so that
Okay, sir. Okay, sir.
for your calculation it must be easy then. So you assume the direction like in a similar pattern, so it must be easy for you to calculate all these forces. Okay, this is
Yes, sir.
just a
Yes, sir.
simple example. So I will give one another numerical and all these things. So all of you please try to solve these ones. Okay, and try to check are you able to understand or not. Okay, so if there is any more doubt, you please come up with that in the next class. I will clarify that, because without doing this,
Okay.
here you see we are considering this joint in joint 1, the direction as it is given. Okay, so you try to solve this and let me know if there is any confusion. Okay, you can also contact me in between also, not in like that you have to ask me in the class itself. Okay, is there anyone have any more doubt? You can ask me, or and in that moment you please give your attendance in the chat box. Okay.
So I have one more question, sir. Hello, sir.
Yes, Michael.
Sir, since we does it mean that this truss is also a determinant structure?
Yes.
So is it also a determinant structure because we're using this summation of
Yes, because
uh,
we are solving this as a by equilibrium equation. Na? Anything we can solve by equilibrium equation, that you can say as determinant structure. If you are not able to solve by the equilibrium equation, you can't say that is a determinant structure. It is the basic. Okay.
okay, sir. Okay, sir.
Anything if we can solve by this equilibrium equation, then we can say that structure is a determinant structure.
Okay, sir.
Okay, welcome. Okay, all of you please give your attendance, and all of you please go through once also. If you have any doubt, you can ask me. Okay. Till then, I am marking my attendance. Integrated roll number 4 is absent today. Integrated roll number 4. Okay, is there anyone left to give the attendance? Okay, there are integrated 4 people now. 1, 2, and 3, 5, I think. Okay, 3. 3 is present. Okay, fine. Anyone left to give the attendance? Okay, then fine. Thank you, all of you. Please, we will join the next class at 10:15. Okay. Thank you all.